Photoelectric effect, the particle nature of light, or how Einstein really became famous. In 1905, Einstein published three papers: special relativity, photoelectric effect, and Brownian motion. But he awarded Nobel Prize in 1920 for photoelectric effect. A photoelectric effect is any effect in which light energy is converted to electricity and was first explained by Albert Einstein in 1905. It may cause them to give off electrons. As you can see, when light source strike the metal, electrons get ejected from the surface. Let's analyze photoelectric effect. Consider a metal foil. Let's bombard blue light sources. As you can see, electrons get ejected. This blue light strikes the metal foil. The foil emits electrons. Let's try out red light. What happened here? What happened here? There is no light is ejected from the metal foil. Well, red light hits the metal foil. The foil doesn't emit electrons. Blue light has more energy than red light because red light has more wavelength than blue light, and for E equal to h nu or E equal to h c upon lambda, energy is inversely proportional to the wavelength. That's why blue light has more energy than red light. How could we get more energy into red light? Now, maybe one red light source is not sufficient. Let's try three red light sources. Still no electron ejected. That did not work. Maybe it's still not bright enough. So let's try about 9 red light sources. Still no electron ejected. What happening here? Still not working. What happens with brighter or more intense blue light? As you can see, before one blue light source ejected 1 electrons. Now let's try about 3 blue light sources. As you can see, 3 electrons are ejected from the metal. So more blue light means more electrons emits, but that doesn't work with red light. Now let's try out 9 blue light sources. What happened here? 9 electrons are ejected, as you can see. So let's talk about photoelectric effect in more details. High frequency light, even from a dim sources. Yes, it is dim sources. Blue light is a dim source. Okay, because it has low wavelength. Okay. So even from a deep light sources can eject from a photosensitive metal. Low frequency light, even very bright, which is red, very intense, cannot dislodge electrons. So light, like all other radiation, is made up of small particles called photons. The higher the frequency, the more energy the photons have. Einstein stated that light interacts with matter as a stream of particles like photons, and Einstein received the Nobel Prize for this discovery, photoelectric effect. It is hard to believe that he doesn't get a Nobel Prize for his special theory relativity or general theory relativity, rather than photoelectric effect. Now let's talk about its brief theory and what equation which is famously known as photoelectric equations. So the photoelectric effect is interpreted with photons and conservation of energy with the equation is light blue light or whichever light sources falls the electron. So without striking the metal, the electrons have the blue light sources have energy h nu, where F is the source frequency. Okay, and phi is the energy which is required for getting electron ejected, which is known as threshold energy, and half mv square is the kinetic energy of electron after the ejections. So HF equal to the energy of his photons. And as you can see here it is in A, H nu is less than phi, no electrons ejected. H nu is greater than phi, photoelectrons ejected with energy left over. As you can see here, this is H nu, this is phi, and phi is what we can say a barrier energy. Okay, energy needed to remove electrons from metal. And this is, you can see, this is phi, this is H nu, and phi is less than H nu now. So H nu equal to phi plus half mv square, and half mv square is nothing but the kinetic energy of the ejected electrons. So this you can see a kinetic energy between the frequency, and this is a slope of h. Okay, nothing but h, and this is negative phi, which is, as you can see, you can compare y equal to mx plus c, and c is negative phi, which is the intercept of y axis. Okay, so higher frequency photons have more energy, so they should make the electrons come flying out faster, thus switching to the light with the same intensity, but a higher frequency should increase the maximum kinetic energy of the emitted electrons. If you leave the frequency the same but crank up the intensity, more electrons should come out, because there are more photons to hit them, but they won't come out any faster, because each individual photons still has the same energy, and if the frequency is low enough, then none of the photons will have enough energy to knock the electrons out of the atom. So if you use really low frequency light, you shouldn't get any electrons, no matter how high the intensity is. Whereas if you use a higher frequency, you should still knock out some electrons even if the intensity is very low. So ejection of electrons is not depend upon the intensity, but depend upon the frequency of incident light. Okay, so as you can see, this is the prize. This is Max Planck, and this is Einstein receiving Nobel Prize for photoelectric effect, not for E equal to mc square, which is his special theory relativity, which is published in the same year, which is, that is 1905. So if a photon hits an atom of a certain material, it may be absorbed by the electron of that materials. However, if the photon has enough energy, the electron is ejected or emitted from the atom. So in this way, light energy changes into electrical energy, which is the application of photoelectric effect. If wires are attached to a photoemitting materials, the electron can flow along the wires, forming an electric current, which is known as photocurrent. So as you can see, a collector plate, this is incoming red light, and electron don't get the plate. If this will be blue light, as you can see, electrons get ejected from the emitter plate and now gets to the collector plate, and current flows through the circuit. As you can see in the left, this is no emitter is not varying. Okay, at emitter no current flows, because electrons can go from this one, the emitter plate, to the collector plate. Whenever the electron reaches from the emitter plate to collector plate, this now completes a circuit, and electrons or current flows through the circuit from the source battery. So why is the photoelectric effect so important? It helps explaining the particle nature of light. First thing, it is basis of the quantum theory. It is used in photo cells, example in solar calculators, alarm, automatic garage, door openers, flash of a camera, and now it will use as a Wi-Fi called Li-Fi. When the light source to the semiconductor is interpreted by the person working through the beam of light, a switch is activated that triggers the alarm called burglar alarms. So now let's discuss some review of photoelectric effect. What it is? Photoelectric effect, the ejection of electron from the certain materials. When light falls upon them, the metals are said to be photosensitive. And who and when discovered? Einstein explained in the photoelectric effect in 1905, but won the Nobel Prize in 1921.